Hello everyone, welcome to this session in which we are going to share the updates on NVHD as well as SEAM on 2022.3 release. Myself, Atul Miskin, I'm Senior Manager for Vibration and Acoustic Solutions, and I'm accompanied by my colleague Uma Mahesh, who is a Senior Application Specialist in NVH. So the agenda for the today is shown on this slide. We are going to talk about first the deterministic optimization, in which the main point that we are going to talk about is the way to automatically update the assembly using optimized values of design variables, followed by some very nice enhancements in CD tire workflow. And these first 2 points will be covered by me. And when we move to SEAM enhancements, it will be covered by Uma. And there are some interesting feedbacks and status with customer interactions on SEAM and some nice enhancements in handling noise control treatments for root cause analysis and diagnostics and usability enhancements. So the agenda is a little bit big, so we will try to be mindful and make sure that we finish all the topics on time. Okay, so starting with the first topic, that is automatic update of assembly with optimized values of design variables. So this is the new enhancement that we have added in the deterministic optimization workflow. So this is just a snapshot of the deterministic optimization feature or functionality in NVHD. We first introduced this feature in 2022.1. It was introduced in Unity, and immediately after introducing it in Unity, Mahindra and Mahindra from India, they started evaluating this feature. And this was a feature that was kind of the reason for them to try it out, to move to Unity also. Then in 2022.2, we introduced this same functionality in Classic because it was majorly requested by JLR. And along with that, we introduced some more enhancements and features like sensitivity parameters filtering, equation-based constraints, mass as design response. And during this time frame, Mahindra also completed the evaluation, successful evaluation. In this release in 2022.3, what we were working on majorly was to work on a mechanism so that the assembly is updated with optimized values of design variables in very few clicks. Or basically, we wanted to make this process very, very easy. And we had a couple of rounds of discussion with JLR, and JLR is going to start the evaluation of this functionality pretty soon. And going ahead for 2023 and the next releases, so we have some more enhancements in pipeline, which are listed below. Okay, so moving on. This is just a snapshot of what is there as a part of deterministic optimization. So we have a complete seamless and integrated workflow for optimization setup as well as result processing. And this is in Unity as well as in Classic. And we have done demos about it during 2022.1 as well as .2 webinars. And this is just a snapshot. I have taken it from during the .2 webinar, which tells a story of this evaluation or successful evaluation at Mahindra and Mahindra. Okay, so this slide just shows a typical optimization workflow in which users will first try to submit for the baseline run and get their baseline NVS responses. The next step is to identify the sensitive parameters or sensitive variables for the problematic responses and problematic frequencies by using some diagnostic techniques like sensitivity analysis or TPA or modal contribution. Once that is done, then the user goes ahead and he sets up his problem for optimization and solves it. Till this point, it's all good. And the next and the important step is updating the assembly with optimized values of design variables. So basically, it's like you get your responses, you identify your sensitivity parameters, and you get your optimized results or get the responses which are kind of trying to satisfy your targets. But one of the major activity which needs to happen even after optimization is updating your assembly or updating your model with the optimized values of design variables. And this is an important step because people don't stop only till optimization. They also want to update their assembly or the model with their optimized values. So right now, till the previous releases, we were successfully able to handle the first three steps. And the step number 4 was something for which we did put a lot of effort, and we will see now how it has been done. So as far as design variables are concerned, what we support as today is for full vehicle optimization, the kind of design variables that are supported are structural parameters like thicknesses, materials like damping, NSM, Young's modulus, and whatever are the material properties which are available. Connection parameters is also can be also defined as design variables, and modal parameters can be also defined as design variables. So these are different type of design variables which can be used for the optimization setup. So this is just one example or one case study that we did recently. So in this, we used our baseline, or we used our NVHD demo model, and there were about the total number of design variables were about 48 for this optimization study. Out of that, around 35 were connections, NVH connections, or connections between different subsystems. About 8 modal parameters were used as design variables, and 5 materials and properties were used as also as design variables. And we were able to successfully complete the optimization run, and you can see the kind of reduction that we got in the responses. So it was pretty good. So we were able to achieve the optimization objectives. And the next step was these are the design variables which get listed, and this is just a snapshot of it, like how these design variables got changed. So basically, this was the nominal value, this was the lower bound and upper bound, and these are the optimized values after the optimization. This is showing it in the graphical way. Now, the important question is, once we do all this, once we get all these nice results, how do we update the assembly with these optimized values? So let's look at what we were doing so far. So we were kind of doing it using manually. So for connections, you have to first identify the connection. You have to literally note down what is the baseline value and what is the optimized value. You have to select that connection, edit the connection, and update that optimized value. So it goes something like this. You go, you open the connection browser. You select a connection. You should know that this was the connection used as design variable. You click edit connection button. You select a property, and you literally go and change the values there manually, or you update the values manually. So this is how update of the connections happen. Now, the next thing is about modal parameters. So if you want to update the modal parameters, you have to select the module, go to the edit representation tab, select the CMS representation, and use this option of use ASCII and change basically the frequency value to the desired or to the optimized value. So select the modes, and here I'm changing it to the optimized value of, let us say, to 80 Hertz, and the optimized value of 100 Hertz almost. So this is the way that modal parameters are updated. The next step is to update the materials and properties. And here what a user has to do is he has to select a particular module. He has to go inside the prepare module mode. So now I'm here in the prepare module mode. And once I enter the prepare module mode, then I need to go and identify which is the property which was modified, or which was the material which was modified. And once that is done, once it is identified, then I need to go and change that parameter manually. So these are the different steps which are purely manual that a user has to go through to update the assembly. Now, this is time consuming, this complete process. For me to update this complete assembly. It took me almost 25 minutes, and it is very error prone. You have to be, really focused when you are trying to do this. And this whole process is something which we wanted to change it completely and make it very user friendly, very efficient, and free of error or free of any issues. So what we did was we went ahead and we introduced the automatic updation process from two places. One is from the post-processing side, and second is from the pre-processing side. So first of all, we will see from the post-processing side. So in the post-processing, you invoke the post-processing GUI for deterministic optimization. You load the result file from your optimization run. Once the result file is loaded, you can basically select the responses and see the comparison of your baseline and optimized response. Here, the red color carries baseline response and the blue color carries optimized response. So you can review the responses. Then once the response comparison is done, then the next step is user can go and review the design variables. And this is where you will see the information of the design variables. And in this option, we introduce setup optimized run. So if you click on this, what it will do is it will invoke, or it will load the complete full vehicle assembly. And it will also load the GUI with information on design variables as well as their nominal and optimized values. User can select and just hit update. And once it clicks update, a new XML is shared with all the values, optimized values, design variables updated. So for example, you can go here and check if I edit the connection, you will see that for this connection, the design variables are automatically updated. So we did not have to do anything. We just have to go and check that connection, and you can see that I had just captured the snapshot, and these optimized values are automatically updated here without any kind of manual editing or anything like that. So this is a fast way. The second thing is about update of the modal parameter. So you can see like this front shot frame here. If I go to CMS rep, the use ASCII button is already clicked on, and you can see that the modal parameter values are already checked on, and their new values are already updated. In case of materials and properties update, all the FE representations for which the materials and properties were updated, it gets saved in a new representation file, and it gets saved in a new file with suffix underscore optimized. And if you go and check the representation file, all these optimized values are automatically updated. So you'll see the thickness is optimized, properties or property values are also optimized, or the new values are automatically there. So this is just if you see, this is a very highly efficient process. All the update, it just happens in one click, and this is totally error free. So users can very efficiently and easily update their assembly with the new values of design variables. You just need to go to the post-processing utility, plot the results, load your assembly XML, and just click update. So this is from the post side. We have also made it possible from the pre side. So the way it works here is you have to first go to the post-processing side. As we discussed, you have to load the response, review the response comparison, baseline versus optimized. When you go to the review optimized tab, there is a new option called as export, which is available here. When you click on this, it will write out a CSV file with information on the design variables along with their nominal and the optimized values. So let's say user has exported it, and and that's it. And if he comes back tomorrow, he doesn't want to go. So what he does is he just loads the baseline XML file on the pre-processing side. And now in the mapping tools, we have introduced a new option called as optimized design. So here, once the user clicks here, he can read in the CSV file, which is exported from the post-processing side. And once he reads it, all the design variables are listed here. and user will get a complete information about it, the nominal, and user can select it, and they just click, they just hit the update button, and all the activities that we just saw in the previous video, the same things will happen. The connections, whatever design variables which were chosen to be updated, they will get all updated. Either they will get updated in the assembly XML, and if it is for materials and properties, the representation file will get saved with the new values. So this is what is a big enhancement that has been done on the deterministic optimization side. The next, and again, this is also a highly efficient workflow. The update happens in just one click and it is error-free. The next thing is about CD tire enhancements. So in case of CD tire, now there are options to create the CD tire in different units for speed. For example, now you can create the CD tire for in terms of kilometers per hour or miles per hour or meters per second. So previously, in the old implementation, the only unit that was taken was meter per second, but now you can create the CD tire in that speed and in those unit system of your choice or user's choice. So you can create it in kmph or in miles per hour or in meters per second. And now in this case, in the new implementation, specifying the speed is a compulsory step. Previously, what we had was we were putting the default option of 10 meter per second, but now user will have to specifically mention the speed for which he wants to create a CD tire so that he's aware for what speed the CD tire is created. And now in the GUI of the CD tire, as soon as the CD tire gets created and he opens the GUI, he will know that a particular CD tire is created for what speed or it is valid for what speed. So these are the enhancements on the creation part. Now the same kind of care we have to take on the analysis manager side also, because all the solver text that will get written out will happen from the analysis manager. So even on the analysis manager, we have provided the options of different units, kilometers per hour or miles or meter per second square. And here also now the user will have to specify the speed. In case of CD tire, depending on which CD tire user has chosen, this speed value will get listed here automatically. So the chances of mismatch between in the speed between CD tire and analysis are 0 now. And it is very necessary to maintain the consistent speed between the CD tire and the analysis manager because you can get difference in the results as shown in the image below. So the blue color results or the blue color curve is for a case in which CD tire is created as 40 meters per second, and even the analysis manager, even here the speed was set as 40 meters per second. So you get such kind of results. But in case you have mismatch in the speed, for example, the red color curve in which the CD tire was created for 40 meter per second, and in the analysis manager it was set as 60. So you can get such a big difference in the result. So it is necessary to maintain the consistent speed, and with this new implementation, we are making sure that the chances for mismatch in the speed between the CD tire and the analysis is 0 or almost minimum. So this is a very good enhancement that has been introduced on the CD tire side, one of the enhancements. The second point is about the width of the patch points of the CD tire. So whenever the user is creating a CD tire GUI, he has to specify. So for example, you see here contact LX and contact LY. So this is basically nothing but the patch width of the patch points of the CD tire. So in the old versions or in the previous version, this width was kept fixed at 200 mm. And no matter what is the actual width of the CD tire, it was always taken as 200 mm. So you can see, and we have seen cases with in some cases, this width was kind of insufficient. So we were ending up in a situation where the width of the patch point, they were not able to cover the width of the tire. So ideally we need the situation like this, where the width of the patch point are able to cover the width of the tire properly. And in some cases where the tires were bigger, it was not happening. And and you can see the difference in the result. So the red color curve is with the insufficient width of the patch points, where the patch points are not able to cover the tire properly. And the blue color curve is the case in which the width of the patch point is enough to cover the width of the tire. So you see there is a lot of difference in the result. So it was the users has to be basically mindful of this fact before that. They have to be really sure that what width the tire has and what he has to maintain while creating the CD tire. But now this identification of the width of the patch point is automatically taken care. So the logic is we can get the width of the tire from the parameter file, and when we the patch of the width of the patch point is we just add 50 mm. So now the this implementation, what is going to happen is we are always going to make sure that the width of the patch points is more than the width of the tire. So these two are very important enhancements from the CD tire perspective. So what we are trying to make sure is that user is aware of what he's doing, and that we are also trying to make sure that the results which users are getting, they are reasonable and they are sensible. Many a times what happens is users are not even aware of such kind of things. They don't know what is the width of the patch points, and they are also aware of mismatch in the speeds of the CD tire analysis. So these two enhancements are very important enhancements, and which is going to make life of the users easy in terms of getting the correct results for their road NVH analysis. So these are all the points from the deterministic optimization as well as CD tire point of view. And the next set of presentation will be covered by Uma. So Uma, maybe you can share your screen and continue the presentation.
Sure, Atul. Thanks. Hello, everyone. Good morning, good evening. So I'll be taking over you the theme enhancements in Unity which have been done in last one release. The agenda for today's discussion is mostly about we have done some enhancements in handling noise control treatments, the sound package, and we have done some improvements and enhancements for root cause analysis and diagnostics, and we have done a lot of usability enhancements based on the feedback from our customer interactions. So I'll be going over them one by one. Due to our developments, we came across few use cases where the handling of NCTs has to be improved. To accommodate those changes, we did a lot of work in .3 to enhance how we can handle the NCTs. So that is one of the major works which has been done in .3. Just to explain, any sound package can be represented with biot parameters as well as measured values in terms of either transmission loss, absorption, or insertion loss. So currently there are different applications of NCT available, but there was no cross multiplication or cross integration. Like for example, currently in .2 we were able to do layer NCT properly. Like let's say you have defined your noise control treatment with thicknesses, with sound package material details and everything with proper thickness. We were able to calculate TL and absorption. But now let's say if user wants to update the effect of transmission loss from a measured data, or if he gets a insertion loss which is measured from by the supplier, he wants to update, there was no integration possible, like one from calculations, one from test, or one from test and one from calculation. So this cross integration was not possible. So and this was very realistic use cases which we came across from different customers. So to solve those issues, we have made a proper list of NCT application which involves layered NCTs, which involves a measured TL, measured insertion loss, and measured absorption. and how we can integrate them into our solution, and how we can have both of them independent of the application, and we can get a proper result when user has multiple applications to improve the results. So as an example, like I said here, there are 4 examples. So for example, if user wants to do layered NCT, or if he wants to apply only measured TL from the test to consider a leak and calculate the absorption, and he wants to he just wants to apply insertion loss rather than transmission loss from a supplier, that is the effect of only sound package he wants to apply, and or he wants to update the absorption rather than calculating from the empirical calculations or test measurements which are done inside in OEMs. So they want to update these values independently across, independent of whether it is a layered NCT or user defined NCT. So to satisfy all these conditions, we worked a little bit in terms of how we can accommodate it. So to do this, we have updated our user defined treatment, which was priorly transmission loss and absorption curve, into insertion loss and absorption. So now user can define the effect of sound package, only sound package without the bare plate in terms of insertion loss, as well as the absorption curve. Uh, you can apply either one of them or both of them. So it will be taken into consideration, as well as now if you have the effect of plate plus sound package and other treatments like a leak or sealants. So if the measured TL is there, you can directly apply them on a connection. So this way, all the 3 conditions of measured data can be applied, and they can be activated or deactivated based on how the user gives the data. So this is how we are able to uh, update the informations. So in similar fashion, absorption can now be applied on the cavities by selecting surfaces, as well as using the user-defined NCTs like in the previous slide. In both the ways, either on a surface or as well as on the cavities, the NCTs can be applied, and it will be updated. Transmission loss, you can update it on a user-defined structural acoustic connections. You can specify it using user-defined transmission loss option. In this way, you can override the current connection which is there, and the TL will be applied between the source and the receiver cavity in such a fashion that the effect of calculated TL can be applied in between those 2 cavities. So due to this all changes, we were able to, in the current matrix, we were able to satisfy almost 6 full use cases, and 1 use case of layered NCT on a cavity surface rather than on a structural surface is still pending. This is in development. So in this basically needs a lot of work, and that's why we targeted for 2023. And with this, the whole matrix of application of both calculations from internal software or the measured data and their mixed usage can be achieved. So in this way, a lot of applications and a lot of real-time use cases have been achieved. So this was a major reason why our improvements with the GM has improved a lot. In this condition, we were able to satisfy all the examples which I mentioned, and currently only the user defined NCT on a cavity, where TL as well as layered NCT on a cavity, both TL and absorption for a particular cavity, if on a cavity surface, if you apply, the development is still going on. So the next, as we had done a lot of work on the pre side, we started from dot 2, we started concentrating on improving the root cause analysis and diagnostics, which forms the major chunk of NVH diagnostics, as it is majorly driven from the post processing side. So we started working on the post processing uh, to satisfy that. First, we started migrating from curve editor to chart manager. So in dot 2, we migrated our whole curve editor to chart manager, but it was under environment variable. In 2022.3, we have removed the environment variable for chart manager. So this is what the customer will see if he is using if it's using the post-processing utility. So in this, we did a lot of changes to support multiple load cases. So previously there was no option to load results from multiple load cases. So now we have added an option to define load cases in the chart manager. Uh, so now he can add results from multiple subcases and see the results in single curve. We can add multiple sessions, which was already done. Multiple pages and multiple layouts. And we have added right-click diagnostic options, both energy contribution as well as excitation contribution for the response. As well as there were few customer changes which been requested, like ability to see the curves, visualizing see the curves, exporting them, copying them. So we have introduced those changes as well. So this have been integrated into the part of a solution. So as you can see now, you can see the curves, you can export as well as copy it into a CSV or copy it into a clipboard and then paste it at a required location. So in this way, you can export the curves as well as copy it into the clipboard. Apart from that, we even currently you can save the layout in a session, which will be further propagated into across sessions also. So currently you can store store the curves or the curve layouts in a single session. Previously in .2, if you once close the post-processing utility chart manager, then you have to replot all the results. So now in the now here, if you close also the old layouts or old pages which you have created, you can get it back, like similar to hypergraph. And most of it is being done using core infrastructure only. Very little changes have been done from the SIEM post-processing side. So once we are able to plot the images properly, see the results, we started working on the diagnostics. So the different diagnostics which we want to achieve to support the diagnostics and root cause analysis include like performance diagnostics on response, like effect of each individual excitation in a load case. So as the number of excitations in each load case is pretty high in general use case of automotive, so you want to identify from which particular excitation or from source the most contributions are coming into the cavity. And the second thing is effect of individual NCTs in terms of whether the transmission loss is having the major effect or absorption is having the major effect, or at which particular region the NCT is not behaving properly. So those all contribution analysis we want to achieve in terms of both transmission loss and absorption. And then further effect of subsystems grouping, like if you want to understand which particular subsystem, like floor, door, roof, or dash, which particular subsystem is transferring most of the energy into the interior cavities. So such diagnostics which will help in identifying and identifying the root problems as well as identifying the major contributors. So these are the diagnostics which we are planning to work on. And currently in this for .3 we are able to implement effect of individual input excitations in a particular load case. And further we are working on as in SIEM, the most of the diagnostics are related to how the energy paths are being energy transfers into the system from source to receiver. So we are working on a way to identify the source energy paths by in ascending order to identify which is the major path from one particular source. You can have multiple paths to the receiver, just like a transfer path analysis in low frequency. So we are coming up with a workflow where you can identify the overall path which transfers most of the energy. And next, we started working on design of experiments to create considering few design variables and responses, and to build further on it. And the last step is to achieve the sound package optimization so that user can use our utility to the fullest. So the effect of each individual excitation in a load case can be possible by right clicking on a response curve and say plot excitation contributions. Once you click on plot excitation contributions, we calculate from each excitations which one is the major contribution, and we show it in a bar chart. So in this way, you will be able to identify which particular excitation or source is the most contributing one. Based on that, you can decide on which particular, whether you have to work on the source or receiver. For example, if the cowl region, you can't add any sound package or you can't reduce the path, so you have to work on inside. Similarly, if there is a chance that you can add some, for example, if you consider this as a wheel tunnel, you can add some wheel covering in outside so that you can reduce the noise. So this gives a major indication if whether it is possible to do some changes at the source level. So this is how you can interpret the tool, interpret the results, and as well as use it to improve the results. So this is the first diagnostics which we have implemented. Then coming to design of experiments, we have added a new icon with the basic implementation of design of experiments. Basically, currently using DOE, we the design variables which can be defined are NCT thickness and material. So this is the GUI where you can add the NCT, and in NCT it will specify how many layers are there. You can choose which layer you want to define. And in that layer, you can either define thickness or material as its design variable. So in this example for here, dash mat and layer decoupler, we have considered thickness as an design variable. The nominal will be auto calculated, and you can give an upper bound and lower bound to which you can calculate the design of experiments. Similarly, in front carpet for a decoupler, for material, he wants to understand what is the effect of material density on his overall results. And similarly, he wants to understand the effect of thickness as well as material flow resistivity characteristics of a rare carpet pile. So he has defined them as a design variables. So once he has defined the design variables, this will be considered for the design of experiments. Once the design variables are defined, you can define the responses. Currently, the design responses are internal cavities for any given load step at a particular frequency. We are further adding different types of responses like across a frequency range, average frequency, RMS, RSS. So those enhancements which we are targeting for next. But currently, you can define you can define the cavity for which you want to calculate how is the effect of design variables at a particular frequency. Once you have defined the design variables and design responses, currently we are using fractional factorial matrix to create the algorithm to create the design of experiments. Using that, you can plot the scatter plot and how the particular cavity, uh, because of this change in design variables, how your response will look like, as well as you can do Pareto plot in which you can see which particular NCT is the most contributing one, and identify the particular NCT design variable in terms of whether it is flow resistivity or thickness, and then plot the and then take a decision on this. So to summarize, in design of experiments and optimization for a sound package, we have completed NCT layer and thickness, material and damping characteristics, as well as now we are going to further add damping treatments, thickness and coverage in 2023. Percentage coverage of NCT on a particular plate, definition of holes and leaks. If there's a TL and absorption defined from a testing, so this also we can define. We are trying to make as a design variables. And further we'll add different algorithms for both doing an optimization, and we'll add few derived responses like RMS, RSS, average response across a frequency range, so that user can take an overall call on the response, as well as few diagnostic tools like scatter plot and Pareto plot are already implemented. We will implement further ANOVA and further interactions in the coming release. Coming to the usability enhancements, we had a lot of interactions. So few of the interactions led us to the usability enhancements. These are the usability enhancements based on the feedback. So unit conversion, drag to plane for a cavity, leakage definition on structural acoustic connections, output file path preferences, mixed mode of color of creating surfaces and default subsystem selection in entity selector, edge selection for plate combination of line and nodes, allowing of creating a plate from cavity surfaces, default solver settings, and multiple load case support. So I'll try to go over few based on the time. Um, to start with, the current units between the low frequency and high frequency, there is always a difference. So because most of the times, based on the measurements, they want to maintain one unit system, and in uh, generally in low frequency FE we maintain 10 mm/second. So to overcome this, we have implemented unit conversion while importing the model itself, as well as we have given a default units for the seam session for that particular model, so that can be remembered. So just to show you, once you import a solver deck, it will automatically identify which solver it is. It will ask for a unit system, and the target unit system will automatically be defined as a default system from the file preferences, so which will be taken into consideration. And currently, if you see, before conversion, everything is in Newton meter, ton, and Newton mm and ton definition. So now we will convert it into MKS unit. Once it is converted, the whole model will be converted into uh, MKS units, and the model will be we will convert the whole model into MKS, as well as the material characteristics and properties will also be converted automatically, and so that you can use them. So this is a major change which we've done in supporting the units. Then further, one more major use case was, currently in old Seam Classic 3D, there was no support of multiple load cases from GUI side, but we had an option and a support from the solver side. So we have enhanced our utilities currently currently in high frequency unity profile, so that now you can create so that we can create multiple load cases, and you can select which particular load case you want to define. So to do that, the first step is to create excitations for all load cases. Once the excitation is defined, you can click on a new icon called SAE load step in analyze ribbon. By selecting this, you can from once you selected this, you can click on SAE excitations from the entity selector and pick the excitations for which you want to create a load case and say create. The load step will be created for that load case. So you can create n number of load cases, and once the load cases are defined, what the next step is to assign them or run in a session. So to run it, we have created a use case where you can select by clicking the advanced options in the run. You can select using the load step options in the run. You can select for which particular load steps you want to run, or you can select all the load cases and run. So in this way, either a single load case or multiple load cases which are there in the XML file, you can run them in one shot, or in a single file, or in a multiple files. So once this is done, you can see the results, and the post processing side also we have supported. As you can see in the chart manager changes, we were able to import as well as see the results for multiple load cases. So the whole pre, solve, and post interactions and integration is all done together. In this way, multiple load case implementation is we were able to achieve in a full scale. So as you know, in high frequency there is a lot of interactions in terms of either damping, transmission loss, insertion loss, or excitations for different load cases. So users requested of capability to update the whole curves which are present in a particular XML file in a single shot, so that once the XML is imported, uh, and if you have a CSV file with same name or with a different name, you can directly import those curves either by overwriting it or updating it or renaming it in such a way that the existing curves can update and you can run and see the difference of the results, or you can you can add them into your curve list so that it can be further used for further maybe excitations or updating your NCTs. So this way, this was a quick way of importing all the curves in a single shot. This is supported for both CSVs as well as XLS. In this way, this helps in importing all the curves together. Um, then other changes were to currently, even though the results which generated in seam out files are not high or not, or the solver time is low, still user wants to store that information and refer it back. So we, using in file preferences, we gave an option to export the out files or the solver deck files into particular export directory so that he can refer them or store them and reuse them. So for each session, it will create a multiple output folders so that there won't be any clash. So this, for example, if two sessions are there, automatically the tool will handle and create two multiple export directories in a defined location, so that both the sessions can run parallelly and run and see the results as well as store them. The other user enhancements which we done are like mixed mode for coloring of subsystems. So these are few minor enhancements but useful in reducing the time and reducing the confusion. So while creating subsystems, user wanted to have a topology view. So we added the topology view so that it gives a clear indication where if there is any break or any overlap which was missing. So it will reduce their effort. As well as in entity selector, always uh, in HyperWorks general, if you select anything on the GUI, it generally by default goes to component. But user wanted to have a subsystem option because that is the most used option in high frequency profile. So we made in this particular profile only to have subsystem as a default option once you click on a session. Similarly, while creating subsystems, user has asked to add an option to select a plate. While creating a plate, if there is already a adjacent plate which has line to it, which has multiple nodes, so user asked an option to select the lines and update it, as well as default solver options based on the unit systems which is defined in the file preferences. So which will help in reducing the time of defining each time for different types of units. So these are the enhancements which were done, and we are still working on improving the usability enhancements from our side, and it will be further added into 2023. I think that's all from my side. Thanks.